All right, guys, we are back. CompTIA A Plus Certification Exam Core 1 Objectives 220-1101. Okay, we are on the topic of networking, more specifically 2.5, given a scenario, install and configure basic wired and wireless small office / home office SOHO networks. Guys, let's go ahead and I'm going to be really honest with you. Look at the wording here. It says, given a scenario, install and configure basic wired and wireless small office, home office, SOHO networks. Okay, so they're literally asking you to go ahead and install and configure. We're not going to do that today, guys. Okay, what we are going to do today is we're going to go ahead and talk about the major topics. We're going to discuss these ideas here, and I'm going to let you know exactly what you need to know, like the back of your hand. Okay, that way you can have the best opportunity to pass CompTIA A plus. Obviously, if you can go ahead and already do this, or if you use Packet Tracer, or if you have some hardware, I would highly recommend that you do this. But what the purpose of this video more specifically is I want to go ahead and make sure you guys know what you need to know, given the situation. So we're still going to go ahead and talk about the core exam objective 2.5. Okay, given a scenario, install and configure basic wired and wireless small office, home office, SOHO networks. But more specifically with today is things you should know. If you have no idea what I'm talking about, that's a clue in regards to what you need to study. If you already know what I'm talking about, don't worry about it. It's a nice little refresher, keeps things fresh, keeps things in your mind with regards to what you should know for this particular exam objective. So the first thing you should know is IPv version 4. It stands for Internet Protocol version 4. It is 32 bits. It is composed of 4 octets. An octet is the same thing as a byte. A byte is considered 8 bits. A bit can only be a 1 or a 0. The silly analogy I talk about is when you take a bite, you start chewing and it becomes bits. Okay, so a byte is 8 bits. A bit can only be 1 or a 0. IPv version 4 has 32 bits and it's broken down into 4 octets. We're not going to focus on the binary, so to speak, right now, but just realize that this is written in binary. Another thing you should know, subnet mask equals the network divider. The network divider is the subnet mask, also known as mask or subnet. So that way you can go ahead and distinguish what part of this IP address is for the network, what part of this IP address is for the host, and you'll get something along the lines like this. If you type in ipconfig, notice here we have IPv version 4 address 10.211.55.3. Its subnet mask is 255.255.255.0. So that lets me know that the 10.211.255, this is part of the network. Okay, this is letting me know, hey, you have technically 250, I think it's 253 hosts available, if I'm correct. Yeah, it should be 253 hosts available. So this number scheme here is letting you know, hey, this is part of the network. This is part of the network. This is part for the host. Okay, as long as you know that the subnet mask is the network divider, I think you should be okay. And let's go on to the next thing. You should definitely know the difference between a public IP address and a private IP address. Okay, the simplest way I can explain this is a private IP address is, I like to explain it like in terms of your neighbor. Okay, your neighbor can have, okay, memorize these here, but here's my analogy between the difference between a public IP address and a private IP address. Your neighbor can have, say, 192.168.10.10. Their neighbor to the left can have 192.168.10.10. I'm talking about the IP addresses. I can have 192.168.10.10. Okay, the neighbor behind them can have 192.168.10.10 as the IP address. And guess what? All of those would be able, there wouldn't be an issue because we're talking about in our own home, in our own local area network, in our own little logical network. Okay, hence the local unique address. Keyword here is local unique address. Okay, we can technically have that same IP address and we wouldn't have any issues. Okay, there's a lot of things going on in the background, such as PAT and NAT, things of that nature. Okay, but as long as you know, hey, this IP address 192.168. Whatever, or 172.16.0.0 all the way to 172.31.255.255, or 10.0.0.0 all the way to 10.255.255.255 is private. Basically, if you should memorize this. So if you look at an IP address, you should say, hey, this IP address right here, yeah, that's a private IP address. How do you know? Oh, because it falls within the range 10.211.55.3. Hey, look at that. 10.0.0.0 all the way to 10.255.255.255. Yeah, that's a private IP address. Okay. On the other hand, public IP address, there's literally only one public IP address. Okay. And that is the IP address that you would use for the world to connect. Okay. So that means when it comes to a public IP address, there's only one of those in the world. You don't want to go ahead and replicate it, or else you're going to have issues. Okay. And it is a globally unique address. That means that the people in China, the people in Australia, the people in New Guinea, wherever they are in the world, okay, they can say, hey, this IP address belongs to this particular device here. Okay. Whereas the private IP address is just kind of like, hey, it's kind of a local thing, and we're using these private IP addresses. So we can technically, if go back to the idea of your neighbor can have the same private IP address and it's not going to be an issue. They have the same public IP address, that's going to be an issue. All right, let's continue forward. IPv version 4, I want to show you this slide first. This slide here. IPv version 4, I'm going to show you the review first because it kind of paints the picture. Hey, you have class A, you have class B, you have class C. You definitely need to know these. What determines what class it is the first octet. Anything between 1 through 127 is class A. This is on the first octet. Anything between 128 to 191, this is class B. Anything between 192 to 223, this is class C. And you can see that it has a nice little logical pattern where class A has one octet that's full, class B has the two first octets that are full, and class C has the three octets that are full. The subnet mask, what's the subnet mask again? That's the network divider. That lets you know which part of the IP address is for the network, which part of the IP address is for the host. So this here just lets you go ahead and lets you know, hey, class A, 1.0.0.0 all the way to 127.0.0.0 subnet mask. This is best for a large number of networks, few hosts per network. Class B, 128 through 191 on the first octet. The subnet mask is 255.255. That's the default subnet mask. Okay, .0.0. This is best for medium number of networks, medium number of hosts per network. Class C, 192 all the way to 223. Subnet mask is 255.255.255. Small number of networks, large number of hosts per network. Okay, the keyword here, guys, is looking at this. Obviously, other than memorizing the numbers, but just realize, hey, class A, best for large number of networks, few hosts. Class B, medium networks, medium host. Class C, small number of networks, large number of hosts per network. Word of the day: IPIPA, APIPA, automatic private IP address. If you look at this IP address, if you see 169.254.0.0 all the way to 169.254.255.255, you have an automatic private IP address. Okay, and what exactly is that? It refers to a feature implemented in Microsoft Windows operating system that allows devices to automatically assign IP address to themselves when they cannot get an IP address from a dynamic host configuration protocol, DHCP server. The best way to explain this is that it's a preliminary temporary IP address in order for you to have an IP address as soon as you connect your computer to the network, in order for you to connect to devices within the network. If for whatever reason you're trying to go ahead and refresh, or you're trying to say, hey, give me an IP address, DHCP server, or if you're connected and you haven't received and it's been a couple minutes and you haven't received an IP address, more than likely, guys, there's something wrong with your DHCP server. Okay, so just remember that. A PIPA is literally preliminary temporary IP address that is automatically just shot into the computer so you can have the ability to go ahead and connect with other networks, with other devices within the local area network. You cannot use the automatic private IP addressing to connect to devices outside your network. Okay, this is only a feature that's for the local network. So hopefully that made sense. If for whatever reason you keep seeing this IP address even after refreshing, more than likely there's something wrong with your DHCP server. We talked about the review. Remember, once again, it's the first portion. Okay, it's the first octet that literally tells you what type of class you're dealing with. A, B, or C. Memorize these numbers. There is class D that's more used for multi-addressing, and there is technically class E that's used for experimental use. I haven't seen it. I haven't used it. If you guys know anything about it, if you used it in your own work or so on and so forth, let us know down in the comment section below, or what uses you've used class D or E in IPv4. Loopback address. The best way to explain this is like sending a text message to yourself. Hey, I don't think I'm receiving text messages, or I get text messages really late. What's going on? The loopback address is literally the cell phone number. Don't quote me on this. It's an analogy. It's a metaphor. The loopback address is literally the cell phone number in your computer that you would go ahead and send a text if you're thinking that you're having connectivity issues. Like you would be like, hey, can I ping myself? Am I getting messages? What's going on? That is the loopback address. Okay, it's literally the address that you would use to send a message to yourself to test for diagnostics, troubleshooting, to see if you're receiving the message. Okay, anything between 127.0.0.0 all the way to 127.255.255.255, you can go ahead, and if you're watching this video and you're not having any issues, I promise you can go to your command prompt right now and just type in ping 127.0.0.1, and you're going to go ahead and get 4 little replies. That lets you know, hey, you're good. You're receiving information. APIPA, we literally just talked about that, automatic private IP addressing. Okay, it's literally the first IP address that your computer will get. More than likely, it's going to connect to the DHCP server, and then you would go ahead and get an appropriate IP address. If for whatever reason you don't, first thing to look at would probably be the DHCP server, if you have one. And here's an example here, 169.254.75.10. Okay, IPv version 6. Okay, something you should absolutely know. It deals with 128 bits. Remember, a bit is either a 1 or a 0. It can't be anything else. It's either a 1 or a 0. 8 bits make 1 byte. 1 byte makes 1 octet. If you have 128 bits, 128 divided by 8 is going to go ahead and give you 16. So IPv version 6, you're going to see something along the lines of 16 bytes, 16 octets. Though I'm not going to really get into it because you can go ahead and decompress this, so to speak, and there's rules and regulations to decompress it. But that's going to be outside the scope for this class, or rather for this particular slideshow. There is no IPA in IPv version 4. I should actually be IPv version 6. So the link local address, okay, the prefix for IPv version 6 is FE80::/10. Remember, APIPA is exclusively only used for IPv version 4. IPv version 6 uses the prefix of FE80::/10. Also know the difference between static versus dynamic. This is very simple. Static is manual. So if they're saying, hey, we need you to statically put the IP address, they're literally asking you to go to the device and you're going to type in the IP address. If they say something along the lines of, hey, don't worry about it, the IP address is dynamic, we have the DHCP server, oh, it's dynamic, so it's going to be automatic. Okay. Gateway, I think of the gateway as going to be a little silly, but it's kind of like that door in Narnia in the closet. It's just like it opens a whole new world. Okay, the gateway in your network is literally the last hop, okay, that it takes to jump into the internet out there in cyberspace. Okay, so the gateway is literally the door that messages would need to come in from the internet, and it's the door that the messages would need, and when I say messages, data would need to go out out to the internet. Okay, so think of that gateway as literally the door, that door to the internet, and it works both ways, right? You have data coming from the internet to your local area network, and you have data coming out of your local area network out to the internet, and that is the gateway. Okay. So internet slash external networks. So that's how you get to external networks. More than likely, if you're going to see something along the lines of, hey, this computer can ping itself. We check the loopback address. We checked the IP address. It doesn't have an APIPA address, a PIPA address. It was dynamically configured. We can talk to other devices in the network, but for some reason it can't connect to the internet. Hey, yeah, check the gateway. Okay. All right. So just keep that in mind. That does it for us, guys. That's literally what it is. So once again, we didn't technically go ahead and do exactly as they asked when they said install and configure. But I gave you guys the information that you should absolutely know, like the back of your hand. So if they talk about loopback addresses, if they talk about PIPA addresses, if they talk about Class A, Class B, Class C, if they say, hey, what's the difference between IPv version 4 and IPv version 6? Hey, IPv version 4 is 32 bits. IPv version 6 is 128 bits. It has a larger pool of IP addresses, so on and so forth. So that information you should definitely know. If you have any questions, comments, concerns, please feel free to go ahead and ask. And that does it for us. And we'll see you guys on the next